Good afternoon, everyone, and welcome to this webinar number 6 of the Zero Emission Building Academy, a partnership between European Copper Institute, Building Performance Institute Europe, and the European Construction Technology Platform. The aim is to discuss the transition to a zero emission building stock. And today we will look a bit around energy renovation as such, but about integrating other aspects and particularly seismic safety. For sure, it would not make any sense to make renovation for energy while leaving a building in a bad condition for structural safety. It could also be for fire safety or electrical safety. In seismic region, the seismic aspect is particularly important. And that's what the eSafe project has been looking at. And we have two representatives from the consortium today to discuss it. What is also particularly interesting is that beyond combining these two aspects of seismic safety and energy renovation, they also look particularly at the end users' involvement, which can be relevant in many aspects. So that's our topic today. So we will have the two presentations and then we will have the Q&A. So our two speakers are from the University of Catania and they work in the Department of Civil Engineering and Architecture. Vincenzo is a professor and doing some research on environmental condition to people, while Venera is working as a urban planner. So we will start with our first speaker, Vincenzo Constanzo, who will introduce us the eSafe project. Vincenzo, the floor is yours. Thank you.
Thank you, Quentin. Thank you, everyone. Good afternoon. I don't know if the camera is working. Yeah. Okay, so nice to see everyone. I will start sharing my screen. Please let me know if it works.
Perfect.
Okay, thank you. Good afternoon again. I'm Vincenzo Costanzo. I'm an assistant professor at the University of Catania in Italy in the field of building physics and technical systems. And this afternoon, I'm very happy to share with you some insights about the eSafe project, what is the main purpose of the project and what are the main technologies and technical solutions we are going to develop and demonstrate through the project. Just to give you a background about the significance of our project and of this research. Currently in the European Union, the building sector is responsible for about 40% of the final energy demand, and this translates to about 36% of greenhouse gases emissions. The European Union is very committed to cut these numbers. So the aim is to cut emissions by 30% by 2030. So it's literally just some years forward. And to be completely carbon neutral by 2050. And all these figures should be referred to 1990 levels. The problem is that these targets are very ambitious. So if we see the histogram, the graph on the left, I have reported the construction period for the building stock in Europe for most of the European countries. And if we give a look at the graph, we can see that the blue and the red bars represent buildings built before 1990. And this represents the vast majority of the buildings actually in the stock. So we have a building stock which is really old and energy inefficient. And some current studies, also developed by the same European Union, said that in order to meet these very ambitious targets, we should renovate the existing building stock at least on a rate of 3% per year. But actually, the renovation rate in every country is much less than that, and it's about 1.2% on average. So we have a lot to do on the renovation side. Besides the energy figures and the importance to decarbonize our environment, we also suffer from seismic risk in Europe. So in Europe, about 50% of the territory is earthquake prone. And in particular, the zones that you can see highlighted here, so some Eastern Mediterranean countries, let's say Italy, of course, Greece, but also Turkey, they suffer from very high seismic risk. And just to give some figures, in the last 50 years in Europe, earthquakes have caused more than 36,000 deaths, and also the need to relocate more than 1.4 million people. It is like a sort of immediate consequence that it doesn't make too much sense to renovate the buildings only from the energy side if we suffer also from a very high seismic risk. So this is exactly what ESAFE wants to tackle, to combine the energy and seismic renovation. And the ESAFE project targets specific building constructions. So we are not targeting all the possible existing buildings to renovate, but we focus on non-historical buildings, which are made of reinforced concrete. So the typical buildings we found after the Second World War for the reconstruction, something between 80 and 90% of this building is made up of reinforced concrete frames. So for these buildings, we propose a combined energy and seismic renovation. The project started in October 2020 and is expected to be finished by October 2024. We have 8 different consortium partners from 8 different European countries, and some of them are also with high seismic risk. The concept is of the ESAFE renovation scheme is highly holistic. So we want to combine not only technical solutions which are very efficient, but we want also to make these solutions affordable for as much people as possible. So in the frame of the project, we also care about cost. So we want to minimize cost. We want to minimize the disruption. So we will see that during the works, the renovation works, people can stay inside the building and they don't need to relocate elsewhere. And we also propose some financial tools to make upfront cost more affordable. A key point is also the social issue. So we need to make people aware of the need of this major renovation. But about this specific topic, my colleague Venera Pavone will talk more in detail later on. From a technological point of view, we want to work to make this renovation works completely from the outside. So the idea is that of creating a new building shell through the use mainly of prefabricated wooden panels. These wooden panels comes in 2 different forms. The ECLT panel, which is made of cross-laminated timber, and this panel has a structural function. So the combination of these panels, which are attached to the existing frame through innovative energy dampers, makes the building seismic resistance. While the other prefabricated panels, called E-panel, they are more for the energy efficiency side. So these panels are also covered with a suitable layer of thermal insulating material. The combination of E-panels and ECLT creates also a new architectural image for the building. In some cases where, for example, the application of ECLT is not convenient, we envisaged the use of some metallic exoskeleton for improving the seismic resistance. And this solution is called E-Exos. From the energy side, besides the improvements due to the better insulation, we have also developed an innovative mechanical system configuration, which is called eTherm. So eTherm is basically a new centralized technical system for the building that provides altogether the thermal energy needed for space heating, for space cooling, and for domestic hot water production. The eTherm concept make use of electric heat pumps. These heat pumps are air-to-water heat pumps. So they take the heat from the outdoor air and then convert this heat into heating or cooling according to the season through the production of hot or chilled water. This water, which is called the technical water, is stored within suitable storage tanks. And then from the storage tanks, it is driven through every apartment into these tanks. These tanks are small storage tanks that combines domestic hot water, of course, for residential uses, and they have also embedded some plug-and-play hydraulic connections to connect to the existing system for heating and cooling. Of course, using heat pumps is very energy efficient. So we produce, for example, hot water at a temperature typically below 50 and 45 degrees. And at the same time, we use renewable energy from photovoltaic panels, which are installed on the roof of the building. So the electricity needed for the heat pumps is provided by photovoltaic panels. Finally, we have also a building energy management system called eBEMS, which manages all the technical systems and which also perform a monitoring of the indoor conditions in terms of thermal comfort conditions and indoor air quality. The aim is that of providing the residents and the people using the building with meaningful information about the current indoor conditions, while also suggesting some actions, for example, the opening of the windows if the air is too stale, to improve not only thermal conditions, but also the energy consumption of the building itself. The demonstration of our concept takes place through pilot buildings. These pilot buildings are free. One of them is located in Catania, southern Italy, and this is called the real pilot building because actually every technology I have already presented will be really installed on this building. We are also working on the renovation of two other buildings located in Romania, in particular a school building in Timisoara and a residential building in Bucharest, where the effectiveness of the technology is assessed through numerical analysis. So in these two pilot buildings, we will not really install the technologies, but we are providing a very detailed design for the local stakeholders that can use this design for getting fundings and so realize the renovation. Now I will present some of the expected energy savings and improvements in the energy efficiency of the buildings. So starting from the pilot building in Catania. So this pilot building is a residential building that was built around the 1960 and was never renovated since that. It is a 5 floors building with the 2 apartments for each floor. And we do not have any centralized system for heating, cooling, or domestic hot water. So every flat is totally independent from each other. And within this flat, we have some basic boilers and electric heaters that provides domestic hot water production and heating of the environment. Just in some flats, we have some split units that provide also space cooling. The envelope is quite poor in terms of thermal performances, as we can see from the quite high U values for the walls, the roof, and the windows. So in order to appraise our expected energy savings, we run detailed dynamic energy simulations using a tool like Energy Plus, and we estimate both the heating, as you can see on the top graph, and the cooling from the bottom graph, energy savings for different retrofit scenarios. So the blue bar represents the current state, and the other dashed bars represent different renovations scenario. We ran also a cost effectiveness analysis, and we found that the best cost effective retrofit solution is that of insulating the outer walls, the roof, and of course using the e-therm concept. In this case, we can expect energy savings for heating of about 66%, and of about 25% for space cooling. And this turns out the amount of energy which comes for fossil fuels is saved in a range between 85 to 95%. In the case of the school building in Romania, which is located in Timisoara, the building once again was built around the 1950s, but it went through a renovation around 2006. And in particular, it was the windows that were replaced during this renovation. Also in this case, the envelope, the walls, the roof, and in minor part also the windows were not that high performing. But in this case, the building was provided with a district heating system for providing heating and domestic hot water production. Once again, in this case, we ran other simulation analysis, and we focused only on the heating energy demand because it was the highest energy driver. So we almost have no need for cooling in this part of Romania. Let's say that a particular aspect from this renovation is that we also considered a mechanical ventilation system with heat recovery, because one of the issues that were reported by the students and the teachers from the school that during the winter the heating system was on, but it was not very well controlled, so there was overheating within the rooms. But because of the stair rail problem also, people were used to open the window. So we had a very highly energy inefficient behavior from the people there. And I'm sure this is something Venera will talk about a bit later. So once again, with the help of these advanced simulations, we developed this retrofit scenario for which savings of about 43% in the heating energy demand and of about 55% in the peak heating power should be achieved. And this turns out to be within a primary energy savings range of 75 to 85%. Finally, for the building in Bucharest, which is, let's say, shares something with the building in Catania. Again, it was built around the 1950s. It has 5 stories, still with an unperforming building envelope, but with a district heating system combined with radiators in each flat for providing heating and domestic hot water production. Also, in the range of 50% for the heating energy demand and 53% for the heating peak power demand. Again, primary energy savings are expected to be in the range of 75 to 85%. I want to stress out, to conclude my intervention, that of course these savings are estimated. We will measure the real savings in the pilot building in Catania, and we will double check if everything, of course, it's on track. But a key point is that we are confident these figures are reliable because of the engagement with the local stakeholders we carried out during the co-design process that was carried out by my colleague Venera Pavone. Actually, I leave the floor to her, so she will explain better what I'm talking about.
Okay, can you hear me?
Yes.
Yes, perfect. Thank you, Vincenzo, and thank you also to Corp Allianz for this webinar, where we are discussing one of the main topics for the future of our city, that is the necessity to spread seismic and energy retrofitting. My task, also Vincenzo said, is in the next minutes is to explore one of the, let me say, dark side of a renovation, that is the social aspect of retrofitting. And there are many issues that can be raised from this perspective, but this evening I'm going to show you what we have done in terms of co-design. Especially I'm going to show you what we have done in Catania. That was the co-design with the goal of a real implementation of the SAFE project. And it took a very long process that lasts 2 years. Okay, bene. Well, when we say co-design, we refer a participatory and co-creative approach where building users are directly collaborate with the professional through the entire design process. With the aim of together identify the best solution, the best design solution, and define it in a common framework. I'd like to highlight that the decision to adopt a co-design approach in SAFE was made with the understanding that co-design is not an additional commitment for the designers, but it implies a shift in the conventional mindset. Indeed, this approach prioritizes what we have named mutual learning. Both resident and professional have the opportunity to learn each other, and specifically professional learn from resident about their needs and preferences, while residents learn from the professionals what can or should be done in terms of technical constraints and procedures. In eSafe, we experienced 2 co-design processes so far: in Catania for a public housing, where eSafe will be implemented, and one in Timisoara, that is a public school. We will work also in Bucharest for the co-design of another residential building in a low-income neighborhood, but the process will take place in the next month. Co-design is conceived not like an event or a series of events, but is a complex social process. So it is expected to be as diverse as the people involved and the issue at stake. So we have not an applicable step-by-step procedural instruction, but in the 2 processes where were structured according to we can say a general idealization. based in the second phase that is co-analysis, and then the co-design phases. To what concern the first phases, the outreach, the initial outreach is essential because it ensures that all the people involved in the co-design are those who can take an effective decision on seismic and energy intervention that need to be implemented. And the outreach phase it's also the phase that provides the basis for developing a collaborative environment since the very beginning. This is particularly true in a context like the one in Catania, characterized by a high level of distress and social vulnerability. The building is a public housing building. It is in a neighborhood that was an industrial, abandoned industrial neighborhood. It's very bad condition. In the case of Catania, that was attended by the resident of the building, by the representative of the public housing agency, also UNICT researcher, and representative from 2 local tenants union. And the aim of that first meeting was to present an overview of ESAFE, all the project, and the future activity of co-design process, and make residents aware of which intervention were covered by the budget of the Horizon 2020 budget, like the one that explained Vincenzo just a few minutes ago, the panel, the CET, the renovation of thermal plants, and that work were not covered and should have been included in the design only if the owners were willing to pay. To give you an example, this was the case of the finishing of the staircase that wasn't included in the Horizon budget, but as a part of the renovation was important to be implemented. In this phase, as facilitator, we also spent a huge amount of time to one-to-one meeting in order to give people clarification and feed an environmental mutual trust. After this phase, the second one was the co-analysis that is aimed at collecting data for the project. The overall purpose is to embed resident relevant knowledge in the development of the energy and seismic retrofitting solution. But this is also the moment when stakeholders learn about renovation opportunities and barriers. In this case, when I use the terms stakeholders, I'm referring to the resident of the building. Beyond data collecting, we can say that the main objective for both stakeholder and professional is to learn about each other's perspective, while we recognize their intrinsic value. Thus, we contact a resident. How we made it? We contact a resident via phone to COVID-19 for an interview protocol made of 18 questions, and the question was about the state and the use of thermal plants, bill expenses. We ask residents to send us copies of the original bills, the presence and use of veranda, the implementation of recent renovation work, and so on. And also in this phase, we led the preliminary survey of the building that was carried out by the team of engineers and architects of the University of Catania. Once a first collection of data was completed, we moved into the co-design phase. The overall goal of this step is getting all the people involved into a designer thinking attitude. And this implies simplifying as much as possible the design process and focusing each meeting on a single topic that can be addressed collectively. So we decide to organize an intensive co-design workshop in the fall 2021. And except for some studio activity reserved to UniCT faculty and students, as you can see in the picture, all the meetings were scheduled over the weekends and located in the pilot courtyard to maximize residents' ability to participate. In the workshop, we face all the aspects of regarding a project, structural, thermal plans, aesthetic issue, and so on. And all the detailed activity are described in a public document, eSafe report of engagement co-learning activity. If you want, you can find Googling eSafe community in Zenodo. Here, I like to point out the use of some tools that help people with no experience in the field of retrofitting and building construction to be able to communicate each other. We work with people also with a low level of education that feel many barriers in express and say what they think or what they desire. This is the case of the using of a photo voice. At the end of a meeting during the workshop, we asked each resident to share via WhatsApp or email a picture of their dream building. What I mean when I say dream building, we asked them to send us an image representing a building similar to theirs, but with a much nicer appearance. And such a techniques use photography as a communicative mean. In the end of that, people we were not necessarily trained to think and talk about the building aesthetic. That might be difficult through traditional communication channel, such as speaking or writing. As I told you, especially in this context that suffer social and economical vulnerability. And during the following meeting, we examined the result of the photo voice exercise with the resident and discussed with them the potential shared preferences. The discussion led to 6 different design ideas that you can see on your screen on the left side of your screen. And student and researcher produced visual materials to be shared with residents and get a collective decision. During the month following the workshop, UniCT experts used the outcome to develop the final design of the building. In this phase, meetings with residents were more sporadic and were structured around very specific topics that emerged while working on the project at a more detailed level. As you can see in the table show, we hold other 4 meetings. Also in this case, I'd like to point out some issues that are relevant if we conceived retrofitting not just a technical matter, but also a social one. This is the case of the removal of veranda. Veranda were very beloved by residents, but need to be removed for 2 reasons. They were an obstacle for the laser scanning survey of the building that was used to design the panel, the CAT and the E-panel, but they were also a legal obstacle to the submission of the application for a renovation permit, since only 2 out of 7 verandas were legally authorized. The discussion with residents, therefore, focused on explaining why keeping the veranda basically meant preventing deep retrofitting of the building. And the discussion triggered a more general reflection on the need to balance single household needs, that is keeping the veranda, with the collective interest that is the ability to file for renovation. At the end, as you can see in the image on your right, residents agreed to remove the veranda under the condition to develop a final design that includes the aesthetic and functional possibility to build new ones. The other issue, as Vincenzo presented from a technical point of view was the installation of a thermal centralized system. In a meeting, Vincenzo and Professor Evola explain how we work the new plans, and we point out to the pros and cons of this new system. Of course, the advantage of the new system was that it will generate significant saving. The main disadvantage was the coexistence of the new system with the current one, to be used only for powering household appliances. And this will mean that residents will pay two bills. Residents show significant concern about this point, about the duplication of bills, and the discussion brought to the light the underlying reason beyond such a concern, which was the centralized nature of the system. And this is not a surprise for us, because we are working in a social system made of people with limited economic means and characterized by a lack of mutual trust when it comes to pay bills. The meeting ended with an agreement that a future meeting will be dedicated exclusively to the calculation of the exact quotas based on equitable distribution criteria and to detail simulation the cost per household. This is the final project Catania as outcome from the co-design. We conduct also a co-design process for the public school in Timisoara, and also in this case we organize a first moment of outreach and stakeholder mapping. The co-analysis was carried out through a focus group with students, teachers, the principal, also other public authorities in the field of education, to raise the main aspect of work on the main aspect to be included in the project. This was the case of the mechanic ventilation out a workshop meeting where we work together with, we can say, craft activities to give an identity to the safe element, take into account design elements for indoor visual and thermal quality. For further information, because time is going on this process, you can visit also the eSafe webpage or simply text us. We would be very happy to share with you all the things that we have done. Just to sum up some of the points that I like to highlight. A co-design process pushes us to conceptualize the building not just as a material entity to be modified, but as a complex system where the material dimension relates to the human one. When we started the process in Catania, the atmosphere was very hostile due to pre-existing conflict between both public institutions and the residents, as well as amongst the residents. And the simple experience of meeting periodically with facilitator pushing for mutual respect, mutual listening and understanding helped in dealing with the controversial issue and reaching out collective decision. The frame of the three creative phases, as I show you, outreach, co-analysis and co-design, follow a conceptual roadmap that facilitates a shared understanding of a participative method that gives value to the mutual learning of people involved, as well as the co-design of solutions. Nevertheless, the co-design process is based on an open approach, which means tailoring the activity to the resources of the context and stakeholders' capabilities beyond the roadmap. The open and evolving nature of this process requires professionals to acquire a multidisciplinary mindset as well as relational skills, and this is particularly true in the case of two projects characterized by a prominent level of complexities that go beyond the simple technical issue, as in the case of working in a distressed urban area. And for concluding, this implies that the role of the professional that facilitates the process is absolutely central, and he is the person who balances time, effort, but overall has a clear idea of the goal that can be reached. And that's all. Thank you.